Carboxylic acid could be prepared with multiple different methods. Okay, we're going to briefly go over, mostly summarizing what we have already learned. Okay, we're going to look at each individual reaction at a time. So first of all, oxidation reaction. Alcohol can be oxidized by the Jones oxidizing condition, right? Using chromium as oxidizing agent. And the aldehyde could also be oxidized with the Jones oxidizing condition or with the Toland's oxidation condition, silver oxide with ammonia. Okay, the reactions have been discussed in the previous sections. The other kind of reaction is associated to the oxidative cleavage. Okay, and alkene could be cleaved using a strong oxidizing agent like potassium permanganate. Okay, concentrated potassium permanganate could cleave alkene. Okay, and under these circumstances, your alkene could be either mono or di-substituted. In the other word, any of these two sp2 hybrid carbon would have to have a hydrogen bonded to it in order for the carbon to be oxidized to carboxylic acid. And the alkyne could undergo similar reaction, and in this case, an alkyne could be oxidized by both the potassium permanganate or the ozone, and the alkyne could be oxidized to the corresponding carboxylic acid as well. The benzylic carbon, as long as there is a hydrogen bonded to it, could also be oxidized with potassium permanganate, generating the benzoic acid. The reaction is first occurred on the benzylic carbon, and the mechanism involved with removing one benzylic hydrogen. Therefore, you have to have at least a primary or secondary carbon over here in order for the compound to be oxidized to the benzoic acid. Okay, and we discussed this reaction in section 15.11 when we discussed the chemical reaction of the aromatic compound. The other reaction occurs when you treat an alkyl halide with a magnesium. Okay, not necessarily restricted to alkyl halide. I'm going to talk about the scope of this reaction momentarily. Okay, once you generate a Grignard, you have a really strong nucleophile over here, right? You have an alkenide nucleophile. The alkenide nucleophile could react with carbon dioxide. In the molecule of carbon dioxide, your carbon is largely partially positive charged, and the carbon is electrophilic. So nucleophilic Grignard could react with electrophilic carbon here, and the pi electron is moved over to the orbital of oxygen. We're generating this reaction intermediate. Okay, and I probably should add some of the lone pairs. So this carboxylate could be protonated or could be more accurately acidified, generating the corresponding carboxylic acid. Show you an actual example. Benzobromide reacting with Grignard, generating the corresponding Grignard, and the Grignard could react with carbon dioxide in a separate step, being acidified, generating this phenylacetic acid. This reaction has relatively high scope in terms of what R groups could be. So R could be primary, secondary, tertiary, allyl, alkenyl, or aryl or aromatic group, as long as your other functional group is compatible to Grignard, and you could essentially making the corresponding carboxylic acid. Same starting material, same benzobromide, you could treat a benzyl bromide with a sodium cyanide, undergoes a SN2 reaction, nucleophile attacks on the benzylic carbon, removing leaving group at the same step, generating the corresponding nitrile compound. This nitrile compound could turn into its oxygen derivative, or in other words, carboxylic acid, under either acidic or basic condition. This reaction, though, only typically occurs on primary halide, simply because your cyanide, if you have a secondary or tertiary halide, your cyanide may also act as a base, carry out the elimination reaction. So the reaction is relatively restricted to the primary halide for this kind of conversion.